Hi, my name is Dr. Eric Christian. I'm the program scientist for the Interstellar Boundary Explorer, or IBEX mission. IBEX is studying the boundary between the solar wind and interstellar space.
There are several boundaries at the edge of our solar system. The closest one we call the termination shock. That's where the million-mile-per-hour solar wind, which expands out from the sun in all directions in space, slows down, becomes more dense, and starts to be diverted away before it reaches the galactic material. Beyond that is the heliopause. The heliopause is the boundary that separates material of galactic origin on the outside from material of solar origin on the inside. And even further out than that, we think there's another boundary, which we call the bow shock. Because the solar system is moving quickly through the galactic material, actually plowing through like a snowplow, we think the interaction makes a sharp jump out in front where the quickly moving in material has to slow down and start to divert away also.
You can see that really well in this animation where the solar wind is streaming out past all the planets and it's blown this bubble in interstellar space. The nearly spherical solar wind termination shock bubble, and then the solar wind slows down and starts moving back into the tail, and then the interstellar gas, which is moving very quickly up here, slows down in the bow shock and moves around the solar system. You can actually duplicate this in your own kitchen sink. If you take a stream of water and bounce it off a flat surface, what you get is a region close to the stream where the water is moving very quickly and very straight. And then suddenly it slows down and you actually see an increase in height where a shock forms in the water. That's the equivalent of the solar wind termination shock. And then beyond that shock, the water is turbulent and flows down into your drain, and that's the heliopause boundary out here. Now, one of the reasons why this is important is because this solar wind that's streaming out to the heliopause pushes out galactic cosmic rays, which are radiation coming from distant parts of the galaxy, and it prevents a lot of these galactic cosmic rays from getting into the Earth or to astronauts on their way to Mars, for example. So the solar wind pushing out sort of forms a force field, if you will, that helps protect us.